Hi, and welcome to part 2 of the chucK granulator tutorial. We're going to talk about envelopes now. In order to create a grain of sound, we're going to multiply our playback from our buffer, whatever sound we want to play back, and we're going to just take a little bit of that sound and we're going to multiply it by an envelope. In this particular case, we're not using sort of the built-in envelope functions that are in chucK, but we're going to have a little sound file that represents the envelope. And then we're going to multiply that sound file by the sound that we want to play back. And it's going to create this little grain of sound, enveloped grain of sound. You can look more into this if you look into some of the theory behind granular synthesis. These envelopes are recommended by Curtis Rhodes in his book Microsound, which is kind of the textbook for granular synthesis. I think the classic one is this one called Gaussian, but there's all these other envelopes. So what I've done, and I've included this in the code file, are create little small sound files, 512 samples long of each of these envelopes, and plus a couple other ones as well. And what we're going to do is we're going to read through these sound files and then multiply this envelope by the actual piece of sound that we want to play back. So we create these little enveloped grains of sound. So the first step is really learning how to multiply two audio files together. All right. So in this kind of demo code, we're simply going to take a sine wave and then multiply it by the microphone input to create ring modulation. Okay, that's a classic effect. So my microphone input is going to be multiplied by a sine wave. All right. So we're going to use the UGen gain. Okay, we're going to create a gain UGen under G, and it's a little bit confusing because gain here in chucK, the UGen, as they say, all unit generators can themselves change their gain. So you have you can take like sine os A, and then you can have A dot gain, or chucK like something like 1 to A dot gain, and that will mean the gain for A will be 1. Okay, so all UGens have a gain. But in this particular case, this is a particular way to add or multiply or scale n inputs altogether. So if you keep adding things to the gain UGen, you can keep adding things, and then you can multiply them together, you can add them together, you can do various things. Okay? So what we're going to do is going to create a gain UGen and then add a bunch of things to that gain UGen. So for first we're going to send it in a patch to our DAC. So we're going to send the gain UGen first to the DAC. All right, and then we can chucK various inputs to the gain UGen. So we're going to have the ADAC, which is my microphone input, the analog to digital converter. And I'm going to chucK that to G, okay? And then we're going to have a sine wave oscillator, and we're going to chucK that as well to G. So now G contains both my microphone input and my sine wave oscillator. All right. Now there's a thing in particular to chucK, which UGens have these operations that you can use. So you have gain, which we already mentioned. You have last, which will give you the last sample computed, et cetera, et cetera, et cetera. But also, in particular, in our what we're interested in is this .op function. Okay, and it's an integer you give it, and whatever number you give it is going to do one of these things. It's going to stop, add all inputs, subtract inputs, et cetera, et cetera. The one we're interested in is number 3, which will multiply all inputs. Okay, so then that's the reason for this line of code here, which is number 3. And we're going to call operator number 3. Oops, on G, our gain. There you go. G.op. And what it's going to do is going to multiply all the inputs so far. So our ADAC and our sine os. Okay, and then we just can simply advance time. We'll just let it run forever or run for a day. And now you have your ring modulator. And if you're not familiar, it sounds a little bit like this. Hello, okay. Kind of sounds like the Daleks from Doctor Who. There you go. So that's simple multiplication. All right, now this next part is where we are going to read through that small envelope file, and we're going to learn how to change the length of it and to let it be an envelope. So here are the actual plots to a number of these envelopes. This one's the green, this Blackman, and then this one's called Expodec, which is kind of like a percussive one. This one's called the Gauss, which is our classic kind of envelope. hamming, which is a little bit more widespread out, and then there's a Hanning, et cetera, Rexbodec, which makes it sound kind of like a backwards sound. 3-stage linear, famously used in by Barry Truax in the early days of real-time granular synthesis. This one's a pulse one. So there's various ones. You have quasi-Gauss, which gives a lot kind of more bell. These overlap more than triangle. In any case, these are all available in the code there. Right, these are all available here in the code right here in the GitHub page. Okay, so basically we're going to treat the envelope just as any other sound buffer, just like our main one of the material we want to read through. So SNDBUF, and we'll call it envbuff. Okay, we'll give it a name. And then we'll chuck something to it. We'll chuck the Gaussian one. A little bigger so you can see. We'll chuck that there to envbuff.read. All right. Now we're going to use our gain just like we learned earlier. We're going to create a gain ugen and chuck it to the DAC. And then we'll add a sine wave. So basically this is a demo. We're just going to demonstrate how we use a little sound buffer as an envelope. So we'll just envelope a sine wave. Okay. Check that to the DAC. Oh, to the G, I'm sorry. Okay, and then we'll also check our envelope buffer, our little sound buffer to the G as well. All right, and then we'll multiply them. All right, now we're going to set a couple different things on the envelope buffer. So we'll set the position, just like we did in the very first tutorial where we read through a sound file. Right? So we're going to start at the beginning of the envelope. Okay? There's a little bit of explanation about how to calculate the actual to calculate how to read through the actual envelope. So we'll declare a duration first. So we're going to make the envelope last, say, 700 milliseconds, okay? We'll store that in a variable we'll call gdur. Now, let me talk through this equation a little bit. So if the actual envelope buffer length is 512 samples long, we'll read through it quite quickly, right? If we're just going at kind of a normal rate, it'll just last what 512 samples last, which is, 512 divided by 44,100. So it's, very short. So what we have to do is we have to kind of lengthen it. We have to read through it very, very slowly so that it lasts at, in our case, 700 milliseconds, right? And this is just the equation that'll do that. You can use this envelope buff dot length. So if we, let's see, hopefully you've learned this, but to print in chucK, you do that. Hopefully this will run. Oops. So you can use this dot length. It's a function of the sound buffer to give you the length. So let's see if that actually printed that out. Yeah, so it's 512 samples, right? So we're going to take the length of the envelope buffer in samples, and we're going to divide it by the amount of milliseconds or samples, I guess. So ms gives you the number of samples in a millisecond. So right there, 44.1 samples in 1 millisecond. So the number of samples in 1 millisecond times the number of milliseconds you want, right? And that's going to give you the actual rate. Okay, so if you take the number of samples in the duration that you want in milliseconds, and you take the length of the actual buffer and divide it by this, that'll give you a frequency, number of times per second that's actually going to read through. So it's going to now read through our buffer in 700 milliseconds. Okay, so it'll do that nicely. Now, finally, we're just going to advance time. On our parent patch. And so now we've multiplied our envelope by a sine wave oscillator, and we get this nice sort of enveloped sine wave. Okay, you can make it very small if you want. Create like a little grain. Okay, and of course you can use repeat if you want to repeat this and do various things. Now finally, let's go ahead and put it all together. So now we're going to take the little bit of the sample we want to read, and we're going to read an envelope, and we're going to multiply them together. So we'll have a little grained sound file, a piece of our sound file. Okay, so let's start with a couple sound buffers. Oops. This will be our main buffer, the source we want to read. And we'll just stick with our glass break one. Check that over. Okay, and then we'll have another sound buffer. We'll call it the mbuff. And we'll read that. Okay, now we're going to have our gain ugen. And then our buffer, we're going to chuck our buffer to it, our main buffer. That contains a little sound file we want to actually listen to. And we'll chuck over our envelope buffer as well. So we're going to be multiplying our sound buffer with our envelope buffer. And then 3 is the multiply command, op. Now we'll do a couple things for the main buffer. We'll start at position 0 for the main buffer we want to read. Again, we can randomize that or do whatever we want. But for now, we'll just start with 0, and then we'll play it at a normal speed. Now for our envelope buffer, again, same thing. We always want to read our envelope buffer from 0 because that's a point. And, you know, we can declare a rate too if you want. I guess the default is 1. So at least we can just leave that for that. Then we'll have a grain duration. We'll have 700 will be the duration. 700 milliseconds will be the duration of our little grain. Okay. And then this little calculation that I talked about earlier, that will be calculating right, the frequency you need to read through so that it lasts 700 milliseconds, and then we're going to move time ahead for just a single grain. Okay, and yeah, I think that should do it. Let's give it a go. Okay, that's an enveloped. Let's make it much smaller. See if we can hear that envelope. Maybe not quite that small. Right, and then of course if we wanted to repeat that, we can stick all this into a repeat. Oops. And there we go. We have essentially pretty much the main kind of guts of our granulator. Now you'll notice we can change a bunch of stuff right already. We can put a new file in there. We can change that. We can change the envelope buffer and have any one of those envelopes that I talked about. You know, one of the ones that Curtis Rose recommends, and I included a couple extras in here, right? You know, you can read from different positions. You can play the buffer at a different rate. Envelope, this will probably stay the same, but you can have different grain durations. All right. So that will wrap it up for part 2 of our chucK granulator tutorial.